to another Roblox video. Today, we're playing the crazy popular fish game. And make sure to hit that like button. Let's try to hit 10,000 likes. If you want to see more of this content, make sure to hit that subscribe button and smack that notification bell so you don't miss out on my next video. Make sure to stay till the end for a special surprise. Now, on to my video.
Alright, let's begin. So, remember yesterday we talked about theoretical probability and experimental probability. Theoretical probability was the ratio of number of times of an event that occurs to the total number of trials, and this is kind of what we've been talking about, right? Putting the events that we want to happen over the total number of events that could happen, and it's what does happen. So the experimental probability we also found was the probability of the event happening based on the possible outcomes. It's what should happen. That's what we did with our spinners, and we actually made an experiment and tried it out, and we put our theoretical probability to the test. So today we're going back to the realm of theoretical probability, and we are talking about something called an independent event. So independent, that word should be familiar to you. You've heard that word before. It's like when you're on your own, right? And no one's going to affect you, right? You're an independent person. So an independent event is when one event does not affect the outcome of the other events. Each event is its own thing, and it doesn't affect my other events. So think like tossing our coin. One coin toss is not going to affect my second coin toss or my third coin toss. Or maybe if you're rolling a dice, my first dice roll is not going to affect my second dice roll or my third dice roll. Each event happens on its own, and it doesn't affect the other events. We're also going to be thinking about compound events. That is an event that consists of two or more simple events. So we're not talking about one single event anymore. We're talking about multiple events. So we're going to take our compound events and our independent event, and we're going to create compound probability. Compound probability can be determined by multiplying the probability of the first event by my second event. So I'm going to take my two events and I'm going to compound them together to make a compound probability. And we're going to find the chance of all of these events happening. Make sure you have this written down on your notes page. So let's go on to our example. So we have a bunch of buttons. Let's first find our total of buttons before we even think about probability. Total is the most important thing. It's going to go on the bottom of every single one of my fractions. So we have our total. We're going to count
1, 2, 3, 4, 5, 6, 7, 8. So my total number of buttons is 8.
Now, let's look at our problem. It says the students draw a button, they replace it, that keyword replace it, and then draw a second button. And then we're determining the probability of each event. So we have a compound probability because we're drawing twice, we're not just drawing once, but we know it's an independent event because we are taking that button and we are putting it back. So we're not affecting future events. We're going to talk about dependent in the future, where we are affecting future events. But right now we're not affecting future events. We're just picking a button, putting it back, and each time I have 8 total buttons, and the buttons are all the same every single time I pick that button. That's what we mean by replace the button. So let's look at our first experiment that our students are going to run. We have our first one, A. It says, what is the probability that a student will choose a square button and then a circle button. Remember, we're putting back our buttons. So picking that square button is not going to affect my total number or my probability in the second round. So let's look at our square buttons first. We have a total of 8 buttons, so I'm going to put that on the bottom. Always remember to put that on the bottom. And then we're going to count how many square buttons I have. I see I have 1 square button here, and I have 1 square button here. So I have a total of 2 square buttons out of my 8. So I can make that fraction 2 over 8. Now some of y'all might want to do some simplification early, and you could see automatically, oh, I can divide the top and bottom by 2 to get 1 over 4. This will help me later when I'm simplifying later. But if you wanted to, you could just leave it as that 2 over 8. Now, we picked our buttons and we put them back. Now, I'm going to pick my circle button. Because I replaced that button, I still have a total of 8 buttons on the bottom. Now let's look at our circle buttons. I have 1 circle button and I have a second circle button. So, it's the same fraction. We have 2 circle buttons out of the 8 total circle buttons. And looking at our past simplification, I can see, oh, this is also 1/4. So I know I'm going to take 1/4 and multiply it by 1/4. And when you multiply fractions, you multiply the top, which would get me 1, and you multiply the bottom, which would get me 16. Because 4 times 4 is 16. Now, if I had not done my simplification, I would have gotten 4 over 64, which you can still simplify to get our 1 over 16. Let's move on to the next one. Problem B says, what is the probability that a student will choose a star button and then a heart button? Let's look at our first event. Remember, we're still replacing. So we have a total of 8 buttons in my first event. And let's count how many stars we have. I see 1 star here, and I see another star here. We have 2 stars out of 8 stars. I could simplify early on, but I'm not going to do that this time. Let's look at our second event. I've put back my star buttons, and I'm looking for my heart button. But because I replaced those star buttons, I have a total of 8 buttons still. Now let's look at our heart buttons. I only see 1 heart button here. So I'm going to make that fraction 1 heart button out of the 8 total buttons that I see. When I multiply that out, 8 times 8 on the bottom is 64. And 2 times 1, by multiplying my top, is going to get me 2. I can simplify that. I can divide the top by 2 and divide the bottom by 2 to get 1 over 32. Now, if I had simplified earlier on, like I did in problem A, I would have already gotten to 1 over 32. But either way works. Whichever one works for you. They both work. Let's look at problem C. Problem C says, what is the probability that a student will choose a heart button and then a hexagonal button? Remember a hexagon is going to have 6 sides. So let's look back up at our example. How many total did we have? I had 8 total buttons, so I put the total on the bottom. And how many hearts did I see? I see 1 right here. So I have 1 heart over my 8 total buttons. I put that heart back into the bin. And then I look at my hexagonal buttons. I have 8 total buttons, so put the 8 on the bottom. And then I look for how many hexagons I have. I only see one right here. So I put 1 hexagon button out of my 8 total buttons. I'm going to multiply out my numbers. I multiply the bottom 2 first. 8 times 8 is 64. And then I multiply my top numbers to get 1. So 1 over 64. Can I simplify that? I don't think so. So I'm going to leave this simplification box blank. So we just get 1 over 64. Let's look at that final example, problem D. It says, what is the probability that a student will choose 2 star buttons in a row? This key little 3-word phrase at the end means I'm going to pick 1 star button in the first round, and then I put it back, and then I pick another star button again on my second round. So we're seeing if I can pull 2 stars in a row. So let's look at my first attempt, my first trial. So I'm going to look at how many total did I have. I have my total of 8. So I have a total of 8 on the bottom. How many stars do I have in my total of 8 buttons? I see 1 star here. I see another star here. So I have 2 star buttons. So I'm going to write my fraction as 2 over 8. Now, remember, I'm putting that button back. So in my second trial, I still have 8 buttons. And even if I did pick a star button, I'm putting that star button right back in the bin. So I still have 2 stars out of the 8 that I'm picking. We haven't changed our number of stars at all. So it's 2 out of 8 times 2 out of 8. Multiply my top numbers to get 4. 2 times 2 is 4. I divide that by 8. Oh, no, don't divide that by 8. I multiply my bottom numbers, 8 times 8, which is 64. And I can simplify 4 over 64. Divide the top by 4. Divide the bottom by 4. And that will get me 1 over 16. That is all for the lesson for today. Make sure that you do the independent and compound event practice. You have 6 questions here on the back of your physical paper that you should have picked up by the door. This is your assignment for the end of class. Please do make sure to turn it in so I can see that you did work today. We have just 6 questions. You've got this. You have your notes. And that is all for today.